All of us remember good old function machines, they were called, in primary. So you'd have something like that drawn on the screen, and you would have to show the number that you get over here. Now, how does this come into functions? Well, very simple. Let's put the value x into this machine. So let's split this into 3 steps. This step, and this step. Now over here, what do we get? We get x plus 2. Nice. Over here, what do we get? We get 2 times x plus 2. Why 2 times x plus 2? Because the x plus 2 from here was put into the times 2. So now it becomes that. Nice. And here you get 2 times x plus 2 minus 1. Why? Again, because this 2 times x plus 2 was carried over here to get this result. So the final result would be 2 times x plus 2 minus 1. Now, how does this relate to functions? Very simple. Functions are essentially these machines. And what do I mean by that? Well, let's take down the function f of x is equal to 2x plus 2 minus 1. Now, if you're unfamiliar with this notation, what this means is that some function, f is just the letter that represents the function. Usually you put an f because, well, yeah, function starts with f. That's why we usually put an f. But it can be any letter. It can be g, it can be h, it can be literally anything. So what this means is that any value that's put in here, in this case x, will just be replaced with the x over here. So say if we were to write f of 2, that would be equal to 2 times 2 plus 2 minus 1. Why is that? Because x becomes a 2, it gets carried over here, this becomes a 2. And what we would get later is we would get 2 times 4 minus 1, 8 minus 1 is equal to 7. Okay. So that's the intro to how functions are notated, are written down, the notation of functions. Now, what happens if we've got 2 functions? So let's write down another function. G of x is equal to x squared plus 2x plus 1, a quadratic equation. And very common, and this is an incredibly frequent thing in past papers, they ask you to write f of g of 2, for example. And you are, of course, given this function, the function f of x, and the function g of x. Otherwise, this question is simply impossible to do. Okay, so fg of 2, how do you do that? Well, first of all, and this helps me and it probably helps many others, is you should write it down in this form. F of g of 2. So now let's just simply break it down. So first let's solve g of 2, and then let's dump or whatever we get over here into the f function. What do we get? We get f of, now g of 2 will be 2 squared, and why? Because we put a 2 over here, so we put a 2 over here, and we put a 2 over here. So 2 squared will give us 4, 2 times 2 is 4 plus 1. 4 plus 4 plus 1 is 9. So we get f of 9. Now f of 9 is simply we put a 9 right over here. So therefore we put a 9 right over here. 9 plus 2 is 11. 2 times 11 is 22. 22 minus 1 is 21. Done. Equals 21. So f of g of 2 is equal to 21. Now, they might as well ask you, this might be a question before or after this one, to say, okay, a of x, the function a of x, is equal to f of g of x. And you have to express a of x. So how to approach this question? Well, first of all, you simply say, okay, g of x is x squared plus 2x plus 1. Now, this is what oh my god, not that. That is what we have to put over here. Now that's quite challenging, and this includes a lot of algebra and a lot of simplifying. So how do you approach it? I'll just do that and that. Okay, wait, I'm sorry. That and that. I'll move it that. Okay. So how do you approach a question like that? Well, you write down 2 times this plus 2 minus 1. What did I do there? Is I just took this and I dumped it into this function. Because that's what it tells you to do. If you put our wonderful bracket, g of x needs to be put into the f function. G of x is this, we just dump it into the f of x function, which just means that we put this here. Nice. So now all you have to do is you have to simplify this, because this isn't simplified, so that's not correct. So you get 2x squared plus 2x plus 3 minus 1, which is just 2x squared plus 4x plus 6 minus 1, 2x squared plus 4x plus 5. Nice. So you just write down that. So you'd say a of x is equal to 2x squared plus 4x plus 5. So a subpoint to that question might be, work out a of x is equal to 0. Now what you do here is just go, okay, we know that a of x is equal to this. So we can just simply say that 2x squared plus 4x plus 5 is equal to 0. So how do we solve that? Now this is just a simple quadratic, and there's of course multiple ways to approach quadratics, but let's solve this one through the quadratic formula because I don't see anything simpler to do here. So a is 2, b is 4, c is 5. Let's first figure out the discriminant, and I'll remind you the discriminant is b squared minus 4ac. It's the thing that you put under the square root. So b squared in this case is 16, ac is 10, so 16 minus 40. 16 minus 40 is a negative number, and therefore there is no solution. X belongs to empty set. Nice. If you don't understand how I got x belongs to empty set, I'll explain it right now. So the quadratic formula says negative b plus or minus the square root of the discriminant over 2a. Now the discriminant is equal to b squared minus 4ac. So if b squared minus 4ac is larger than 0, then you can take the square root and then you get 2 positive answers. If the discriminant is equal to 0, then this is equal to 0, then you get only one answer. Because, well, the square root of 0 is 0. 0 cannot be positive or negative. 0 is just 0. Now, if this is smaller than 0, then you get a negative number over here. And can you take a square root of a negative number? In GCSE? No, you can't. So there is no solution. So x belongs to empty set. Okay. Now a bit more of functions. So functions, of course, can be graphed. And in fact, when you graph something, so f of x is equal to, let's just say, 2x plus 3. And f of x is equal to y. And you have to graph this. So let's just draw the graph. Let's draw the coordinate plane. Boom. Nice. Okay. So, in case you don't know how to draw graphs, I will be having a video coming up on that. But just right now, let's go. So 3 is the y-intercept. So that's over here. Then 2 is the gradient, so it should go like that, and like that, and like that. So overall, the graph should be somewhat like that. And I'm sorry for that little point there, it doesn't match. But yeah, overall the graph should be somewhat like this. And a question like this is usually either 2 or 3 marks. Why? Because first of all, you need to figure out the gradient, so they check the gradient. Then they check for valid points. Actually, now that I think it will probably be 2. Okay. What else is there to know about functions? Yeah, so what else is there to know about functions? Really nothing, pretty much. That's all that you need to know about functions for the GCSE level. Then they just complicate them slightly by adding them into equations. So you would get something like f of x is equal to, I don't know, x squared plus 2x plus 5. And then you'd get given, I don't know, f of x plus 2 divided by 2x is equal to 0, and you'd have to solve it for x. Now, of course, what you would do here, and I hope you realize this, you would take this, you would dump it into the, you'd get an equation. It wouldn't be very pretty, so it would be something like x squared plus 4x plus 4 over 4x squared plus 2x plus 4 over 2x plus 5. Now the 2 cancel out, tra-la-la. So yeah, and then you just have to, oh yeah, equals 0. So then of course you just have to solve that and you'd get the solution, hopefully. This is probably just as hard as functions go in the GCSE. It doesn't get really harder, and this stays the same for both of the exam boards, so CIE or AQA / EdXL, whichever exam board you have. That's essentially how far they take it in the GCSE. Then in the IB, of course, it gets more complex. Now that actually brings me to the next topic, and I was planning to put this in a separate video, but okay, since we're quite ahead of time, why not put this in the same one? And, oh my god, what was that? This topic is inverse functions. Now, what are inverse functions? Inverse functions are the inverse of a function. So let's take my function over here. F of x is equal to, you know what, let's get a different one. 2x plus 5. Oh, sorry, my 5s are terrible. 5s look like s's. Okay, so how do you figure out the inverse? And what is the inverse? So the inverse is, okay, so you know how if you put a 2 over here, if you put f of 2, you will get it's equal to 9. Now we are looking for a function that would take in the 9 and it would give us the 2. So something that does the exact opposite of function f of x. Now there's a wonderful trick to do that. So you replace f of x with y, and you go y is equal to 2x plus 5. Now you have to rearrange this equation so that x is the subject. So what would you do here? You would simply go 0 is equal to 2x plus 5 minus y. Then you'd go negative 2x is equal to 5 minus y. Therefore, x is equal to 5 minus y divided by negative 2. That's it. That's all you do. And now, you just do a bit of trickery, and then you swap them back. So you get that the inverse function of x, and this is how you write down inverse. So you put f, the name of the function, and then this little dash, like that. A little, what's the word? Yeah, apostrophe, there, a little apostrophe. And that's how you denote inverse functions. So you'd get f of x is equal to 5 minus x divided by negative 2. Now what did I do here? I just took the x and I took the y and I replaced it with an x. And now let's just check whether this works or not. Let's take the value that I tested it with. Let's take the 9. So let's put 9 into here. What do we get? We get 5 minus 9, which is equal to negative 4. Negative 4 divided by negative 2 is equal to 2. Okay. Now let's put the 2 into the original function, into f of x. We get 9. I should over here. So this just proves that it works. Now let's look at an example that's slightly harder, and let's end the video there. So let's go quadratic. F of x is equal to x squared plus 2x plus 7. And you have to figure out the inverse function of x. So how do you do that? Again, you replace it with a y. Y equals x squared plus 2x plus 7. And you have to make x the subject of the formula. Now, this is where it gets slightly complex. So y, obviously, is some number. Because now we're just trying to rearrange the equation. We can forget about the functions. Now we just take y as some number. So what do we do in this case? We just go, we carry the y. We go 0 is equal to x, oh my god, x squared plus 2x plus 7 minus y. Now, does this remind you of anything? Well, of course, this reminds you of a quadratic equation, where coefficient a is equal to 1, coefficient b is equal to 2, and coefficient c is equal to 7 minus y. And for this, we can write down our quadratic equation. X is equal to negative b plus or minus the square root of b squared for minus 4ac. Now, negative 4ac would just be equal to negative c because a is equal to 1, negative 4c, sorry. So negative 1428 plus, no, minus, sorry, minus, what's am I doing? Yeah, minus 4y all over 2. And what do we get? We get that x is equal to negative 2 plus or minus the square root of 4 plus 28 plus 4y, and all of that over 2, which is simply equal to negative 2 plus or minus the square root of 32 plus 4y over 2. Now this is this actually very gently touches on another topic from GCSE mathematics, which is surds. Because here, if you've got a good eye for surds, you can see that we can just take out the 2 from the square root, and I will do a separate video on this. We can just get 8 plus y divided by 2, which I hope everyone that is looking at this video can see. You can just divide everything by 2, get rid of the fraction, and this is what you get. Negative 1 plus or minus the square root of 8 plus y. Now, you don't have to forget that all of this time we're just trying to figure out the inverse function. So what do we do here? Well, we say f inverse of x is equal to negative 1 plus or minus the square root of 8 plus x. Done. Problem solved. And this is just as hard as inverse and just basic functions go in the GCSE. Thank you for watching. This was Mikhail Shalashov from IGCSmart. And see you next time. Thank you.